there, Mrs. Wagner here. I am filming or doing the Unit 2, Lesson 3.5, the extension activities. This is slide 7. And I have a little container of ice here. It is a solid. So we are going to see what happens to mass when a substance changes state. So we know that mass is the amount of stuff inside of matter or an object. So I'm going to place my beaker and ice on the scale and let it just kind of settle out here. And see if I can get a reading. Okay, it's increasing. So when I put it on the scale, it started out at 30.7 and now it's at 31.9. So why do you think that's going on there? Interesting, we're now at 32.5. All right, so we're going to put in our notebook our starting mass to be 29.6. So that's where it started when I placed it onto the scale. Okay, so we're going to see here what happens. I'm going to come back and we're going to see what the mass is when we have some water. So as this ice melts, as it changes states, we are adding energy just by being in the room. So I took this out of the freezer and it's in a solid state. So as it starts to get energy added to it, we're going to see it melt. And when we have water and ice, we'll take a mass reading, okay? All right, I have here some ice the same ice that we massed, and it's melted a little bit. So we've got a mixture of ice and water. So I'm going to place it back on the massing scale. 30 grams. Oh, that's kind of jumping. Here it's 30.8. Woo! Look at that go up. Interesting. You know, I have a fan on. I'm going to turn that fan off. Hold on. I'm also going to move away from it. All right. So we are seeing this increase. Look at that. What do you think is going on there? I'm going to reset the scale, see if we get the same results. Huh, look at that. So that is interesting, isn't it? We started out at what, like 29.89. So we know particles move as they're separating, right? So I'm wondering if that has anything to do with why the scale is moving. Okay, it's kind of hovered around 31.2 now. Oh, there it goes. Okay. So what should we put for ice and water? There's no like snapshot that we could put there for a number. It's just kind of hovered now right around 31.3. So maybe we want to say around 31. But keeps jumping around. All right, so that's an observation. So when we do these kinds of things, we make observations about what's going on. And so that is an observation. We see that the mass doesn't just settle and stay, okay? But we do know that particles are moving, so maybe it's causing the scale to, change in some ways. All right, so we'll let this completely melt, and we'll take a reading and find out what the mass is at the end when it's completely changed its state. All right, you all, I have just the water here in the container, and I'm going to place it down, make sure it's at 0. And then we'll see what we got here. 30.0. See that? Oh, 30.1, 30.2. All right. And we're hovering around 30.2. Oh, just went down to 30.1. Okay. So we're going to say right around 30.1. It's still there. So around 30.1. Okay? All right. So let's take a look at our mass between ice and then water. We started out at 29.6. Okay? It hovered and it kept jumping around that 31. It went, like when I first put it on, it was below 30 grams, and then we saw it kind of go up a little bit, and now we're back down to 30.1. So if we were to average the mass, so if we took 30 or 29.6, we added 31, and we added 30.1, we would get an average of about 30 grams, okay? Now, does that mean mass is conserved? Do you average to see if mass is conserved? No, you don't. I mean, that's going to give you an inaccurate picture. But because we saw the scale kind of go up and down in the middle there, and molecules moving as it's melting, staying right around 30 is probably a pretty good estimate of the mass, whether it was ice, ice and liquid, and then liquid. Okay? So we're going to say, for the most part, mass was conserved. So it's not a super easy yes or no here, but we would lean more towards yes. That mass was conserved. Okay, how about what kind of change occurred? This is a phase change. Is this a physical or a chemical change? It's still H2O, just in a liquid form. I did not add any other substance to this, and it didn't make a new substance. It just turned to a liquid form, okay? So this would be a physical change. All right. Okay. So that's the last one of our extension activities. The last slide. So at this point, you should have all of your slides completed, and you can go ahead and turn that in. All right.